Hi and welcome. In this video I'm gonna teach you how to build this project. The project is about building an Android app to communicate with an nRF52 based development kit over BLE. The communication is set to controlling the states of the LEDs 3 and 4, getting the states of the 4 buttons, getting the level of a potentiometer, and getting the level of the coin cell battery. The project has two parts. The first one is about building the nRF52 firmware. The firmware is based on the nRF5 Sdk and uses Saadc as a toolchain. The second part is about building the Android mobile app. The app is based on the Ionic framework and uses Angular for the front end. The Ionic framework is a front-end SDK for developing hybrid mobile applications using web technologies such as HTML, CSS, and JavaScript. Okay, so let's have a quick look at what we're building. Starting with the Android app. The app has three pages: the intro page, the scanner page, and the dashboard page. The app default page is the scanner page. If the intro page wasn't yet displayed, like in the first time, the app will redirect the user to this page. The intro page is for letting the user know what the app is about, and it is also used to explain to the user why the app needs to have access to the location of the device. And as you've heard, the app needs to have access to the location of the device. It is necessary for scanning for BLE devices. The app actually does not use any location data. After requesting and granting the location access using the continue button on the third slide in the intro page, the app will navigate back to the scanner page. In the scanner page, and after enabling the Bluetooth and the location, you can scan for your devices using the top right search icon. If the device is available, it will appear in the devices section, and you can connect to that device using the connect button. That will connect to the device and navigate to the dashboard page. In this page, there are four sections. The first one, which has two toggles, is used to turn on and off the LEDs 3 and 4. The second section is used to display the 4 buttons states. The third one, which has a circular progress bar, will display the potentiometer level. The fourth one will display the coin cell battery level. For the nRF52 firmware part, starting with the LEDs, we're controlling the LED 3 and LED 4, and we're using the BSP, which is the board support library for that. For the buttons, we get the states of all the 4 buttons, and we're using the app button library for that. We read the potentiometer and the battery analog values using the Saadc peripheral, and we're using a timer to trigger the sampling and convert these readings to voltages. The Saadc resolution is set to 12-bit. The potentiometer level is calculated based on the VGD value. The 3 volt CR2032 coin cell battery voltage is converted to a level using the conversion function provided by the app util library available in the nRF5 SDK. For the BLE part, we're using a custom BLE service with 3 characteristics. The first characteristic is for handling the potential level. This characteristic has the read and notify properties enabled, so the app can get the potential level once connected to and subscribe to it so it gets notified of all the new levels. The second characteristic is for handling the button's states. This characteristic has the read and notify properties enabled, so the app can read the button states once connected to and subscribe to it so whenever the button states change, it gets notified with the new states. The third characteristic is for handling the LED states. This characteristic has both the read and the write properties enabled, so the app can read from it and write to it the LEDs 3 and 4 states. Additionally to the custom BLE service, we have the battery service, which hosts the battery level characteristic. We use that to handle the level of the coin cell battery. Okay, so let's do a quick test for the project that we're building. Okay, let me enable. Okay, here is my phone, mirror in. Okay, let me enable the other camera here. Okay, and there it is. So here I have the nRF52 840 developer kit. The application is running on the developer kit. Okay, the developer kit is powered through the coin cell battery here. This is the CR2032 3 volt. And here we have the potentiometer, the analog potentiometer. The analog potentiometer middle pin is connected to pin 3, and the other pins are connected to VDD and ground. Okay, Now, the development kit is running the application, but now it is actually on. This question here is on, it's turned on, but here the application is in sleep mode. So let me wake it up, and here you go. So here in the application, I've set the LED1 to indicate the advertising, and as you can see here, the LED1 is blinking. So the application is now advertising. Okay, good. Now let's move to the application part, to my phone. So here I have the application here, the Android application. Let's launch it. Okay, here it is, load in. Okay, and here we are in the intro page. This is the slide 1, slide 2, and this is the third slide. Okay, we hit continue. We allow the location access. We make sure the Bluetooth and the location are enabled. Next, wait, scan. And there it is. It found our development kit. Actually, I've added here, so I have added a filter in this page here, so it only display all the boards that have this name, so we don't get other nearby the BLE devices. Okay, good. So here we have the name of the device, our development kit, and here we have the MAC address, and here we have the RSI. Okay, let's connect to this development kit. We hit connect. You also have this little notifications is on the footer. Okay, good. So here we have the name of the development kit, a disconnect button, and in the fourth section, as we said, this is for controlling the LED3 and LED4. And as you can see here, the app indicates that they are off, and as you can see here, they are actually off. So let's turn the LED3 on. And there you go. It is on. Turn it off. Good. Now for the LED4, on, off, on, off. Good. Now for the buttons, let me push the first button. This is press it, release it. Next button, press it, release it. Third button, press, release. Fourth button, press, release. Good. Now to the potentiometer. Okay. Now let's move the potentiometer. And there you go. And there is the end. Let's move it back. Good. One note about this type of potentiometer is that they are not good. If you have a better one, just use it. Use a better one if you have it. Also make sure the connections are steady, because if the potentiometer just moves a little bit, the reading will change. Okay, good, that's good, it is working. Now for the fourth section, and as we said, this is for the coin cell battery level, and as you can see, it is 15. Okay, that's it. And here in this page, in the dashboard page, you have this disconnect button here. If you press it, it'll disconnect from the development kit. And as you can see here, the development kit is now returning to advertising. Good. That's it. That's what we'll be building in this video. Okay, now let's move on to, before diving into the code, let's have a look at all the tools that you need to have in order to start the development. Okay, so first thing first, for the nRF52 firmware side. Okay, let's mean good. Okay, for the nRF52 firmware side, you need to have the nRF5 SDK version 16 downloaded and extracted. For me, I have created this folder here, and I have named it nRF5 SDK, and another folder inside it, version 16. This is where I have extracted my nRF5 SDK version 16. Good. Next tool that you need to have is the nRF command line tools. You need to install this tool and make sure you get the latest version for your operating system. Good. After selecting your operating system here, you can download it from this link here. Good. Next, and as we are using the Saadc toolchain, you need to have Saadc Embedded Studio installed, and you can install it from this page here, as you can see here. They are available for many operating systems. And you just download. Next, you need to have an nRF52 based development kit. You can either use the nRF52 development kit or the nRF52 840 development kit. I'll be using this development kit for testing. You can also actually use any custom development kit made using an nRF52 based SoC. You can actually use any nRF52 based development kit. So if you build a custom board using an nRF52 or like I don't know nRF52 or something like that, you can still use it. But the problem here is that I'll be focusing on the nRF52 SoC and the nRF52 SoCs, and those are the main SoCs or the onboard SoCs of the nRF52 development kit and the nRF52 development kit. If you have other SoCs, you can just follow the steps; they are the same. This should be working for any nRF52 based SoC. Good. You also just make sure to make it for the buttons, for the buttons to make sure they are set for the pins same as the development kit, and also for the LEDs. The potentiometer will be on the pin 3, so you also need to make sure it is on that pin. Good. That's it. Next. Before the next step, actually you need to have, as I've mentioned before, an analog potentiometer. You maybe need some jumper wires and maybe a small breadboard. Good. The next tool that you need to have is the nRF Connect for mobile. We'll be using this application to test before building until we build our application. Good. This application here is available on both the Google Play Store and the Apple App Store. Good. That's it for the nRF52 firmware side. Now for the Android app side, the application, and as we said, it will be based on the Ionic framework. So to have that set, you first need to have Node.js installed. If you don't have that installed, just head over to nodejs.org and install the LTS, and install the LTS version. Good. Next, then you can start installing the Ionic CLI. Okay, but before installing the Ionic CLI, you need to make sure that Node.js was installed successfully. So to check that, you need to open your command prompt and hit node space -v and press enter. This should output the installed version of Node.js. Next, you need to make sure that npm, which stands for Node Package Manager, is also installed. This tool will also be installed with Node.js. Good. So to check this, npm space -v and press enter. This same should output the installed version. And we go. Good. Now to install Ionic, just copy this command here. Just hit npm, and as you can see, we are using npm to install Ionic. That's what we need to make sure it is successfully installed. So to install the Ionic CLI, just hit npm space install space -g for globally and Ionic /CLI. I missed the L here for the install. 2L. So npm install -g Ionic /CLI and press enter. That should install it. I have that already installed, so good. Next, you need to have Java development kit 8 installed. This is necessary for building the Android mobile application, the APK file. And you can download the Sdk here 8 from this page. It is available for many operating systems. Good. Next, you need to have the Android SDK downloaded. There are two options actually. You can download the Android SDK, the Android Studio IDE, and this will also download the Android SDK. So the Android IDE will have the Android SDK included. or you can just download the Android SDK, and we're actually just concerned about the Android SDK, and this is where you can download the Android SDK. Good. I recommend downloading the Android Studio IDE, so you can easily install the Android SDK. Okay, next we need to have an IDE for building the Android, for building the Ionic app. For that, I'll be using the Visual Studio Code. If you don't have that installed, please install it, and here you can download it in this page. Just hit download, and you can download it in this page here, and there you go. Okay, next, after installing all your tools, you need to head over to your environment, your system environment variables. You in this system properties here, you need to check environment variables, and then you need to make sure that the Android home is set for the SDK. The variable Android home set for the SDK location, and the Android SDK root here is set for location. Actually, I have downloaded the Android Studio IDE, and the Android Studio IDE I have installed the SDK here in this section here. So let me just open it so you can see how the SDK is set. So press it here, SDK, and there it is. This is my Android SDK file. This is where the Android SDK files are. Good. So you need to make sure that they are there, or in any location, and just add the location here. Good. To add a variable, if you don't have this variable, just add new, and you can edit variable name and add the variable value. The variable value will link the path to the files. Good. Now you also need to make sure that Android SDK root set to the same. Also, you need to check the path. Make sure the these the Nordic semiconductor, Nordic, the nRF command line tools. This actually will be added automatically once you install the nRF command line tools. And here we have also the SDK platform tools, and here we have the build tools. You need to make sure all these are set. And here where the npm was set to. This is set automatically, so you don't need to make sure to worry about it. Good. This is there are also these system variables here, like for the RGB here of the Android SDK, and here also the Android home. It's also set in here. Good. Now let's get started. So head over to the nRF5 SDK, which is 16, and in this folder here, create a folder, new folder, and name it projects. And in this folder here, create another folder and name it BLE underscore peripheral. Good. Now I back to the nRF5 SDK and head over to the examples, then BLE underscore peripheral, then locate the BLE underscore app underscore template, which is the template project, and copy it. Copy. Head back to the SDK, then to the projects folder, then to the BLE peripheral project folder, and paste the template project here. Now let's change the name. Let's change its name. Let's make it tester. Let's go tester. Go now. Open this project. Head over to the X. Delete these files. We don't need them. Back. Delete this one. BLE underscore app underscore template. Okay. So here we have 4 folders. The first one is for the default SoC on the nRF52 development kit. This one is the emulated version. This is for the other for another SoC that the nRF52 development kit supports. This is for the nRF52 H40 development kit, which is mainly for the nRF52H40 SoC. The other one is the emulated version, which is for the other SoC that the nRF52H40 development kit support. Okay, so for our project, and for me actually, I'll be using the PCA 156, which is for the nRF52H40 development kit. The steps will actually be the same for any nRF52 based development kit, and I'll have also the PCA 140 folder set for you, so you can easily use it or test it. Okay, so just let's delete those. I don't need them. Okay, so the development will be based on the PCI 156, but I'll also update the PCI 140 for you, so you can easily test it on your development kit. Okay, so here PCI 156 is 140. This is the soft device, and in this folder here we're just concerned about the Sager and the config file. Other folders, just delete them. So as I said earlier, all these steps can actually be used to build the application for any nRF52 based development kit. So if you have the PCI 140, you can just follow the same. Okay, now just continue. In the S folder we have those folders. Okay, let's change the name of the folder. To easily do that, just open this file here on using the Visual Studio Code. Okay, okay, now for the first file here, just hit rename, mouse right click and rename. Here app underscore, let's make it tester, and in this same folder here just change those also, so it should be tester. This is an easy way to change an example, a project name. This is better than do it in the IDE. Okay, so let's do the same for this one. So our name, make it tester. Make sure this the same name, you use the same name. Good, that's it. File, save all. Good, close it, and there we go. We have the name, the project name changed. Good. Now the first step that we're gonna tackle in this project here is creating the custom service. So that's the first thing that we need that we'll be starting with, is creating the custom service and add it to this project here, and see if the application is advertising our service, if the service is available in the application. Good. Now to add the custom service, when I head back to the project, to the BLE underscore app underscore tester project, and here in this directory you're gonna create a folder, and let's name it custom underscore BLE underscore services. This folder should be used to host all the application custom services. And as you can see here, I have put it in this project folder here, so it can be accessed with all the different versions for the different development kits. Okay, here in this folder you need to actually create another folder for our custom service here. We'll name it BLE underscore cus for the custom service. And inside this folder here, you need to create two files, the BLE underscore cus.c and BLE underscore cus.h files for the custom BLE service. To easily do that, just open this folder here in the code, Visual Studio Code IDE. Okay, so open this folder here and add new file, name it BLE underscore cus.h, and another one with BLE underscore cus.c. Good, close all that, and back to the project folder here, access our developer git folder, then it's one of these Saadc. Now back, we need to update to add in another file here in the configuration folder. Just copy this file here, copy and paste it in the same folder here, and rename it app_config. This file here, which name is which stands for the application configurations, will host our application configurations. The other file that by default available here is the Sdk Configurations. This file here hosts most of the Sdk configurations that actually are necessary for this template project that we're using. But for our application, we will be just adding our configurations in this file here, in this application config. It is recommended to just not touch this folder, this file here, this Sdk config, and just use this app_config file to host our application related configurations. Now let's close this. Oh, we need to open it again. Okay, head back to the project file. BLE app_tester, and is one for this Saadc, and open this file here. This should launch Saadc Embedded Studio with our project open, and there we have it. Okay, so the first thing we need to do is add the configuration, the app_config file in here. Just add existing file and locate the app_config. And for our custom service, you need to add a folder here, and let's name it custom underscore BLE underscore services. Inside this folder here, you're gonna add existing file and locate the BLE_custom service.c file. Good. Okay, so one step here. So we need to clear all these definitions here. Just Control A and delete and save. I'm gonna add some header here for these disclaimer, copyright and things here. Just paste it. Next, same thing here for this one. You can just add some. Okay, paste it, copy paste, and F, and change these to app. Let's go config_h. The other one app_h. So this end definition is for this one. Good. Now next, to have this application configuration file enabled, you need for the compiler to access this file here, you need to activate it. For that, you need to copy this variable here and head over to project options, common preprocessor, and preprocessor definitions. You're gonna paste it here under new line and paste it, and make sure there is no space left like this. Make sure there is no space left there after you've added the variable. Okay, and then okay. Next, and as we've added this custom BLE service here, we need to add it, to include it in the included directories. So first, let me copy this link. So here, why was here? Okay, so just copy here and back, open here, options, common preprocessor, and here in user include directories. Those are the directories that Saadc will look for the files you add to the application. So add a new line and paste this one here. change this to the backslash, but we're not yet done. The figure actually for looking to this file here. So just okay, let's head over to the Sigger folder. This is the Sigger folder. So for Sigger to find our custom BLE service, it need to back one file, two directories or two folders back, three folders, then into this folder here, which shows our custom BLE service. So it needs to back 3 times in the directory. For that, you need to add 2 point and a slash. This one is for backing one directory. So this is 1, 2 point slash. This is 2 point and a slash. This is 3. So we have a back of three directories or 3 folders. Then in this directory, in this 2 directories back, which will look for the custom BLE services folder and enter the BLE Underscorecast folder, and in this folder here, then it will look for this BLE Underscorecast.c file. Good. And hit OK. Same. Close this one, and then main. Good. Now let's start with creating our service. First, we need to add here. We need to add the BLE Underscorecast.h file, so we can include it. Give me just some header here. This is some header saying that this is the BLE Underscorecast file for the custom BLE service. So first, we need to include the BLE Underscorecast.h file. Say this should host our definitions for the service. Okay, so let me access this folder here. You just right click, go to definitions, and here we go. Here we are in the BLE Underscorecast.h file. So in this file here, same, just adding a little header here. Next, some includes. This is the std int, as we're using some as we will be using some int variables, uint 8 underscore t and uint byte and 2 byte, uint underscore uint 60 underscore t. Okay, this is for the BLE service command, Sdk command, and we need also the app error. Next, we need to define an observer priority for our custom BLE service, which will be 2. This is the default, the standard actually. Each BLE service has this one by default. Next, we need to add a definition for the BLE Underscorecast instance. To do that, you need to create these definitions here. This is the definition, the macro for defining a BLE underscore instance. There it is, and we'll be using this one here, this definition here, to access our custom BLE service in the main.c file. We also need this one here for the name, and here we have in the SDH, which is the soft device handler BLE observer set, and here we have the priority of the service, and we also have the event here for the service, and this is the name where it goes. Good. Next, we need to define the custom service UID base. This is a custom service, so it will be a 128-bit. So for that, I've set the custom service UID base to. Just to make it easy, as you can see here, we have 11, 12, 13, 14, 15, 16, so you can easily use it or write it. If you want to use, there is also those website for generating a random UID. You can also use it there to generate a random UID. Okay, so I have here the base UID. One thing to mention about the base is that this is where the service will be replaced. So this actually UID base will be the same for the service and actually all its characteristics. The only part that will change is this part here. If you want to use a 16-bit UID, you just change those two values here. If you will be using a 32-bit UID, you'll change all these here. And just a note, this service here is reversed. So for example, here when you scan for your device, you will see that it'll start with here. So service 000, then this 22 will be the end value. Good. So next we'll add the custom service UID. This is it. So this is the custom service UID 16-bit. So this is 10.0.0 will be replaced here. Good. Next, for the characteristics. So the first characteristic is the button states characteristic, and it has the UID 16-bit UID 0x10.01. You can see here that we still have the 10, and we just add a 1 here. So so everything is related, as we have the same service. Next, for the other characteristics, we have the potential level characteristic, and we have the LED states characteristic. And here you can see 1, 2, 3. Good. That's it. Next, we need to add the custom service event types, and for that we have, as you can see here, we have the button states and the potential level. We have the notifications enabled, so we need to know whenever the notifications are enabled and are disabled. And here in the LEDs, we need to make sure to know when the client write the LED states. So whenever it writes, we need to get that event, so we then read what he written, what he write. Okay, for that we need to have these events here. First events is for the notifications enabled on the button states characteristic. Next one for disabling the notifications. Next for enabling the notifications on the potential level characteristic. Next disabling notifications, and the other one for the LEDs characteristic, which is for this event will occur when the client write the LEDs states to this characteristic. Good. Next, we need to have a structure here to hold the data that will be passed to the application on this event. With this event here, this will host our LED states. Next, we need to add another structure here that will be passed to the event. This is for the event, and this is for the LED states here. And this is the structure for the custom service event. Good. Next, a declaration for the custom service type, and it is. Next, custom service event handler type. This defines the input of the custom service event handler function. So we'll take the custom service structure and the event. And the events, as you can see, the events are here. Good. Next, we need to add the custom service initialization structure. This will contain all the options needed for the initialization of the service. Let's paste it here. So we have in this service here, in this service initialization structure, we have the event handler, and we have security modes, the CCCD security modes, as we are using as this characteristic here has the notify property enabled. You need to set the security mode on the CCCD level, so the client or the application can actually enable or disable the notifications. Same also for the potential level. It has the CCCD, which is the client characteristic configuration descriptor. This is used to enable and disable the notifications. So in order for the application or the client to enable or disable the notifications, it needs to write to this CCCD, which is the client characteristic configuration descriptor. And to allow him to write to this CCD, you need to add a security mode. And this security mode will set it to open, so it can write to it. Good. Next, we need to add the custom service structure, which is this one. It hosts the event handler, the service handle, and the characteristic handles. So we have the first characteristic handles, second characteristic handles, and third characteristic handles. Button state, LED state, and potential level. As you can see, we don't include the other one because it does the other characteristic here, because it doesn't have the CCCD, the client characteristic configuration descriptor, because it doesn't have a notifier property enabled. Good, but here you need to include them all. This is for the handles, and they are necessary. This is what the what the BLE stack or the sub device uses to pass the values, like when you write to a characteristic, when you read from it, or when you send a notification. Okay, next we need to have it has here the connection handle, and here the UID type. And as you can see here, we are using a custom BLE service, so the UID type will be a 128-bit. This is a vendor specific, a vendor a vendor specific UID type. Good. Okay, next we need to head back to the custom BLE service.c file, and you need to create some functions here. The first function that we need to create is the event, which is the BLE _cast _on BLE events. So this is the event that will be forwarded from the BLE stack to this service. As you can see, it takes the BLE event and context, and the BLE event here, as you can see, we are just concerned about the write event. You can see here. So we are just concerned about the write event here, and when we have the write event here, we just pass it to another function, which is the onWrite, to check this event on which characteristic it occurs. Okay. So for that, we need to have add the onWrite function, which is this one. This is the onWrite function here. It takes the custom service structure and the event receive it from the BLE stack. Okay, so the write event, this is the write event, getting the write event from the BLE _event, this one, and in event gas.event.parameters.write, get the event. So in this service we have three characteristics. So if the write, so we need to see this write on which characteristic it occurs. So the first one that we'll be checking is the LED state. So if the write event occurs in this characteristic here, it should be the LED states. It should be that the client or the application or have written the LED states, and for that we need to get them. To have that, we need to add the event parameters command.data. We need to read it from the P event write data. As you can see, the P data, this is what we've defined here. That's it, with the length. Params command, this is this one here. This is the command, this is the params command. So it will be params command dot p _ data. Yeah, this is it. Params command data _ p dot p _ data. So with that, we copy the data here, the data available in this write event here. We copy the length, and we raise this event here. So the application means that in the main.c file, we know that we get we have the new LED states, and so it does just read from these. Okay. Next, we need to forward the event. This is for the application, so the application know that this event occurs. Good. Next, that characteristic that will be checking if we are racing to it is the button states. The button states actually does not have a write, does not have the write property enabled. The only property that it has and it is written that it might be written to is the CCD, which is this client characteristic configuration descriptor. This is for enabling or disabling the notifications. Good. So if the client have written to this characteristic, we need to check if the what he written is for enabling the notifications or for disabling it. For that, we use this function here and we insert the data here written. Okay, so if this is true, so it is enabling the notifications, so we have to put event.event type BLE state BLE button state characteristic notification enabler. Otherwise, if the value written is for disabling notifications, where is this event? And again, we pass that to the event handler so the application can know about it. Next characteristics we check if we are written to is the potential level, and it is the same as the button states characteristic. We just have the notify property enabled, which can be written to the CCD. For that, we need to check if what was written is for enabling the notifications or for disabling it. If it is for enabling notifications, what is this event? If it is for disabling it, what is this event? And we pass those events to the event that occurs, one of them that will be one of them, to the event handler, which will pass it to the application. Good. Next, we need to add the BLE underscore the custom service initialization structure, initialization function. This function will be used to add the service and its characteristics to the BLE stack. Okay, so first things first. Let me add it here. So we have so this is the function. This is function for initializing the custom BLE service. This function here takes the custom service structure and takes the information needed to initialize the service, and it return an error code. If everything went okay, it will return an error success. If not, it will return an error code. Okay, so we need in this function here, we need an error code, and we need the BLE UID, and we need this one here. This will be used to add the characteristics. As you can see, BLE underscore add underscore characteristic underscore parameters dot t. This will be used to set the characteristic parameters and add it. Good. Okay, so first thing, we need to add the service, initialize the service, we initialize the event handler, which will be the event handler. We set the connection handler to default, which is invalid here. Next, UID base, we add the UID base. This is the UID base we set here. This one. And next, we add this UID. This is vendor specific vs soft device BLE underscore UID underscore vendor specific add. You will add it here. This will set the UID type to 128-bit. And after that, we check if everything is okay. So if it is, we're good. We continue the execution of the next codes, line codes. If not, we return. Next, this is type. This function will actually set the type, so we get the type here. BLE UID.type is BLE is the P underscore custom service structure UID type. Here we set the UID. This is not the base, which is the UID 16-bit UID here. And here we add the service. This function uses to add the service to the database. So the SD soft device underscore BLE underscore gas underscore service underscore add. BLE gets service type primary, BLE UID, and we add the service handle. And same, we check if everything is okay. If not, we return an error code. Next section is for adding the characteristics. First one, we'll be adding the button characteristic. First thing we add here is the button's characteristic initial value. This characteristic here will have 4 bytes, as we have 4 buttons. So each button will take a one section, a one part. Okay, so next we clear these add parameters here. Then we set the UID for the characteristic. We set the UID type, which will be the same for all. I just already set here. Good. Next, initial length 4 bytes. This is bytes. Maximum length is in 4 bytes. Initial value is this one we see here, 0. Next, we enable the read property and the notify property, 1. Next, we set the security level. So in the read access, we allow the read access. You need to make sure that you allow the read access. Otherwise, the client or the application won't be able to read from this characteristic. Next, we also need to set the write access on the CCCD, so the application can enable, so the client or the application can enable or disable notification on this service. And last, we add the characteristic. This is characteristic underscore add. This is function for added. So takes service handle, characteristic parameters said before, and here it takes the characteristic handles. This is what we set here. Those are characteristic handles. Next, we set the same as the service or other functions. If everything went okay, we continue. If not, we report the error code. Next, for the potential characteristic, same as the buttons, we have the initial value here. We have just 1 byte, so it will be just 1. We set it to 0. Clear the add char parameters and set the UID, set UID type, initial length, maximum length, initial value. And here we have the read and notify, enable them, read access, sec open, security open, client characteristic configure script to write access, sec open, and add the characteristic. Takes service handle, takes characteristic, add char parameters, which is this one we said before, and here we have the characteristic handles, same here as we define. Next, same again. If you don't have any error, just continue. If you have any errors, just return. Next is for the LEDs characteristic. We have 2 bytes as we have 2 LEDs. Same, we clear the add the characteristic parameters. We set the UID type, maximum initial length 2 bytes, maximum length 2 bytes, initial value this one. Characteristic read, enable the read and enable the write, and we should have the read access security open, and we should have the write access security open. And again, we add the characteristic using the function, takes the service handle, the characteristic parameters, and here the LEDs stays characteristic handles, this one here. And same, if there is no error, we just continue. If there is any error, we return. And if the code just reaches this point here, means that everything went okay, so we return an error of success. Good. Next function that we need to have is for updating the potential level. This function will be used in the application side, which is in the main.c file. So for that we need to include it here. This function will be used to update the potential level, and it takes the custom service structure, the potential level, and the connection handle. This this notification actually sent here using the cats hvx parent. Here we set the length of the data. We clear the params, set the type of this notification here. This is a notification. Set the handle, which is available on the characteristic handles dot value handle, p data, the pointer to the data, which is 1, and the length is this one here. That's it. Next function, as we also have the buttons states characteristic notification. So we need to add same function here. This function is for updating the button states on the button's BLE characteristic. Same for it is the same for this function here. There is the custom service structure. Here we have an array, so just pointer, and here the connection handler. We get the length, clear the parameters, this one, and set it to HVX notifications. And here I set the handle to the buttons states characteristic handles dot value handle, and here the pointer to the data, which is 1, and here the pointer to the length, which is 1. and we send. This function uses it to send this the notification. This function actually here will be will also write. So it writes the value to the characteristic and reads the notification. So the client can know that the value has changed on this characteristic. So saving this file here and back to the .h file. As we have added the functions here, we need to include them also here. So for the first one, which is the BLE cast on BLE event, this one, make sure you add the comma, the semicolon at the end. Next, custom service initialization structure, this one. Next is for the potential characteristic level update function, this one. And next for the BLE custom service states update, button states update. And that's it. Make sure all the functions are set also in here. Well, the event, custom init, custom service init, potential level update, and the custom button states update. Save this file here. .c file here, which is the .c file. Good. Okay, I think everything is good. Now back to the main.c file. We'll delete these commands here. First thing we need to do is include our service. So include which is BLE underscore custom service.h file. Save it. Next, we need to change this name here to let's change it to the nRF52 dash divkit. This is the name that the application that will look for, or which will filter for. Okay, so nRF52.5 52 divkit. Good, that's it. Next, we have this manufacturer name here, but it is not used. If you search for this definition here, you can see it is just available here, so it is not included. Just leave it there. We have the app advertising interval, which is 3 in the units of 0.625. Okay, that's good. It's like the normal one. It's within the range, so you can easily connect to it. Okay, here application advertising duration. This is one, and this is in milliseconds. This is 3 minutes. Yeah, this is 3 minutes. So here, this app advertising duration, if you look for it, it is set by this function here, as you can see here. This is advertising initialization function. So what actually happen here is that this is actually the advertising duration is set the timeout. So if the application is advertising 3 minutes, it will time out. The advertising will time out. And if the advertising is timing out, let me check for the event handler here. Okay, so there it is. So just looking for it. So if it times out, and there it is, it will report this BLE advertising underscore event underscore idle, and for that it'll sleep. It'll enter the sleep mode, and this is where the sleep mode where the application enter the sleep mode. So one way of disabling the application to not sleep mode, to not enter the sleep mode, you can the first thing is that you can enlarge this one, make it bigger, or just add this thing here. So for example, you can make add a line here and make this f, first this one, and f def, if defined. So if we have if this advertising duration defined, we set this one. If not, we don't set it. So for example, if we have this one, this will be set. But let me just comment it there first. Let me comment it here. Save it. Let me look for it now. And you can see it is great. So it will not be used. In this way here, you can have the application advertising all the time. So like if you are doing some tests like that and similar like that. But here, as you can see here, this definition here, if it is defined, it will enable this line. If it is not defined, it will not enable it. If it is not enabled at the time, the advertising won't time out. Good. So let me just comment it out. So it's into sleep mode after the 3 minutes. Observer privacy, configuration, minimum connection interval, maximum connection interval, slave latency, connection supervision timeout. It's all defaults. Bandit. Okay, so to add our service after including its header file, we need to define it here using this function here, which is this one. This is for defining our service. We give it this name, as we've done here. You can see the name. We save this file, Ctrl C with Ctrl S. The next thing we need to set for having to add our service is in the services section. But before getting to that, let's check this one here. As you can see, it says your job uses IDs for services, use it in your application. The problem of adding your service to this advertising your IDs here is that our service is a custom service, so it's a 128-bit variable, so it'll take about, let me check, 128 divided by 8, that's 16 bytes. It will take 16 bytes on the advertising packet, and as you might know, the advertising packet just have 31 bytes, only holds 31 bytes of data, and the advertising packet actually has many other hosts, many other variables. One of them is the device name, and device name, you can see here, it is actually a little bit long. 1 2 3 4 5 6 7 8 9 10 14. This is 14 bytes. 14 bytes are already taken by this one. So if you add your custom service here, which is 16 bytes, the advertising packet will be mostly full. So for that, if you add your custom service UID here, your name might not be fully displayed. So for example, if you set your device name to nRF52 divcat, and you've added your custom service UID here, your name might not be shown fully. So you might have just nRF. You might just have nRF as the device name, as the space that the device name will take is already taken by your UID, by your custom service UID. So for that, just leave it there. One good The good thing about having your custom service UID here in this advertising UID is that when you develop an application, a mobile application, and the application will scan for your device and you want this application to just find your device, you can add your custom service UID in this here, and you can just filter based on this UID, on this custom service UID. Then your application will just find your device and filter all other devices. But there is another way to achieve that, to achieve the same feature, which is filtering based on the name. So you just set the name of the device that your mobile application should look for, and this is what I've done. I just set it to nRF52 certificate. So if found certificate, that's the device that should be looking for. Good. Okay. So next we need to add the service here, and there we go. The services are added using these services init function here, and it already have this QWR module. Let me just add a function for that, so it can be easily added here. So it will be this one. This will be static void QWR underscore init. It's a taking void, open here, bracket, and close it. This is QWR initialization function. Now we'll add our service here. Okay, so our service will be initialized using this function here. This is the function that is used to initialize our service. It's the same error code. We have the init function here. This is the init function that we define in the init structure we define here. We set it to 0, we clear it, so we suggest the event handler. We just the only thing that we need to set here is the event handler, and then we use this function here to initialize our service. So just copy and found. This is the function that we're using. Good. Next, and as we have added here the custom event handler, we need to add it also here. So for that, okay, let me add this function. This is it. We're not concerned about this one at this time. As you can see, this is the custom service event handler, and those are the events we set here. See, those are the events. So here we have the LED states. So if we have the LED states, we just log them to the URL. That's weird. And this is where the data came from. You can see here. This is coming from this one here. As you can, the event. Here. This is the data. Cool. Next, we have the other event, which is the notification enabled on the button state, the notification disabled again, potential level enabled notifications, and potential level characteristic notifications disabled. Good. That's it. Next, we need to add those initialize function to the service init function here. Clear all that, and this will be just copying this first one. Should be this one. State, and next we add our service. Clear this void here, make sure it's semicolon is added, and save. That's it. Now we need to move on to the main function, which is here, and you need to do an update here, which is changing this services here. it should be the services init function should be before the advertising init function. We should initialize the service first, then initialize advertising. Change this one here. Let's make it tester application started. Good, we save and okay, let's build the solution. Okay, it'll take a little bit of time. In this time here, I'll be plugging in my board. So let me just remove this potentiometer here, and let me turn off the board. Remove this coin cell battery, and plug it. It is still off here, and let me plug it in. I don't have packets. Okay, let's just wait till it finishes the compilation, and I will turn on my development kit and erase the already flashed application, and we'll run our new application in it. Okay, well, let's compile in. Okay, let's see what we can do. Okay, let me. Okay, so just check this file here. We have the device name, advertising, duration. Okay, let's remove this your job. You can just leave this one here. This is the device information service. This is just a 16-bit. This is just a 2 bytes, so it won't take much on the advertising packet. Good. This is the timers. Remove all that. This is for initialization application timers. This is the appearance. We don't need it. The appearance might be could be good in like if you are like developing a keyboard or something like that, a device that should appear. Should have an appearance. Custom event handler. Okay, we have CVS. Yeah. Okay, good. This is where the application starts. Where the application's timers starts. This function used to have the application enter the sleep mode. And this is the advertising on advertising event. So the first event that we get once the application starts is this one, advertising event fast, and you get this login here. And this is actually what sets the LED1, for the advertising. If you are looking for this here, oh, we have an error. What's that? Oh, an end. What's that? Okay, we just build again. Oh, I have missed something. So when we add a custom service, you need to set this variable here. So Control F to look for. I just look for UUID here. Next, and here it is. It is the nRF52 software device handler BLE vendor specific UID count. So if you add a custom service to your application, you need to add it here, a custom service. And as I said, we will not be touching this file. So for that, we just move on to this app configuration file, config and set it to 1, as we just add one service and save it. We should cancel the build and build solution again. Okay, cool. Back to the main.c file. Okay, again. Okay, this is what is used to okay, where we're here. So if you're looking in this one, this BSP indicates advertising. I don't know, it doesn't work. Okay, there it is. Advertising indicates. If you're looking for this one, okay, anyway, if the secret is built in a function, sometimes there is some lagging as I have a a slower PC, that's why. Okay, so this is the function that sets the LED 1 for the advertising, to indicate the advertising. This function we use it for that. BSP indicate advertising. Okay, so the advertising actually, the indication of the advertising is the flashing. Okay, and the advertising actually set to LED to the LED 1 by default in the template project, and this is what we're using. The next event is the idle event. This will occur after when the advertising times out, and this is what happens. The application enters the sleep mode. So you can easily just command the first one here. Each one to be defined and each one to be set. The timeout want to be set, and for that with that the application will just advertise. Or just you can command this line here. If you command it, even if the advertising times out, it won't sleep. It won't enter the sleep mode. Again, this is the BLE event handler. This is when we have the events of the BLE. Well, disconnect event, disconnected, event connected. See here, if we have the connected event, we have the BSP indication set to indicate the connection that it is connected, and the connection is also set for the LED 1. But here, the type of the indication is just turned to LED on, so just a solid. Next here we set the connection handler, as we get from this event here, and here the QWR. Connection level event assign. This is for the QWR service. Keyword write. Next we have this air Physic update request. We have the GADS timeout. This what will be, we'll just disconnect. Where GADS event timeout, you just disconnect. This happens when you are connecting to the device, when the application connected to the the application connects to the device and takes longer time. You just disconnect. Next, this is the BLE stack. BLE stack init. This is some device handler enable request. Default is -BLE enable. This function here actually, you can see here the RAM start. As actually here, the application sets how much RAM it can use. So for example, if the RAM allocated to the application is low, it will be indicated, it will be reported with this function here. As you can see here, if you have options into the project, again command preprocessor and hit no linker, I guess. Let me check. Yeah, linker. It's on the linker on this section placement macros here, and here where the RAM start and the RAM size are defined. This is the RAM start. Okay, so if the RAM size set there is low, it will be indicated with these functions here, with this function here. It will be reported. Yeah. Okay, this function will take the RAM, initialize it here, there in the project. I don't know, linker files. And this function here will take the RAM. If the RAM is low, it will be the soft device actually will report that error, and it will tell you what to update. means that how much RAM you need to allocate to the application. And I will actually tell you the values of what to update. Good. Next, this is the peer manager init. This is for the bounding. When an application or a client bound to your application, which that is running on the development case. Okay, this is the bounds. Take a bound, magic, press, boom. This is to delete the bounds, here. Peer manager peer is delete. And here we have the BSP event handler. And as I mentioned before, for the buttons we'll be using the app button library. It is easy to use than this one. But the good thing about this BSP event library is that it can also report when a button is long pressed. So if you need like a long press of a button, you can use this BSP library. Okay. But here the app button library is easy to use. You'll see how we will be adding it. It's pretty simple. Okay. Here you can see BSP event sleep. This event will be generated by the buttons that is allocated for the sleep, for intended sleep mode. Here it is the 0, the button, the BSP button 0, which is the button 1 on the development kit. And here the disconnect event. I think what it is also on the button 1. And this is the function for disconnecting. Here. Good. I just have one note for you here, is that this m_connection handle. This connection handle here is what indicates that your application is connected or not. So if this m connection handle, it has a default value that we've set for the application in the first here. Okay, let me look for it. Okay, it has many tabs. That's it. So if this connection handle is equal to BLE connection handle and valid, this means that your application is not connected. But if it is not equal to this invalid, means that your application is connected. So for that means that if your application is connected, you can then disconnect. But if it is not connected, you cannot disconnect. So for that you need to check for this connection handle here. Okay, good. The application here is actually built. So let me just here. Okay, let me turn on the development kit here. On it is advertising. First thing first, let me erase its flash memory. So erase our program here. For that, head over to target, connect G-Link, and target erase all. This should erase the ball, and it is erased. As you can see, it is not advertising anymore. Good. Okay, let's save it and let's build and run. What is it here? And the application is been built and run in our development kit. But as you can see here, the LED is not advertising. So I think there is an error in the code. It's not running, and it is actually it will be an error because actually when we add, as I've told you, for the RAM size, and as the RAM actually is set before, is set in the application linker settings. So if we add a custom service, this custom service needs more RAM. So for that, the soft device will report that your application needs more RAM to be allocated to it. So for that, to check that, and as you can see here, you can't access these little nref log info functions here, reports here. So for that, okay, so actually Sdk Embedded Studio have a terminal emulator available, included, and I've actually added it here. So if you don't have that included, just head over to Tools and Terminal Emulator and hit Terminal Emulator. But before, so you can use your terminal emulator, you need to set these parameters first. You need to set the baud rate should be 115/200, data bit 8, flow control known, and you also need to make sure that the port is true. Here I have the development kit, which is G-Link reporting to COM19. Good. And that's it. Once you have all that, you just hit this one. This is for enabling it. And here you go. We have the errors, the warning. You can see here the RAM error. You'll have this error here every time you add a custom service. It's not all the time, but the first time. If you add the custom service the first time, you'll have this error here. And actually, if you add more, you add more, like another custom service again, or with mini characteristic, or you've added like another peripheral, you might have this error here. Okay, anyway, this error says here, so you just create a so you can copy, so you can copy it here. Okay, it's first change, it tells you, this is the function I've told you about. The soft device tells you to change the RAM start location from 2016 to 2017. So for that, just head over to this project, options, then common, then linker, then here, in this one here. So we have the RAM start here, it is 2216, 2260, it should be 2270. And the RAM size, it is DDA0 and should be DD9. And okay. As you can see, we have this returned error. It is the nRF error, no memory. That's what I think is this error here. No memory. Cool. Now let's try again. Build and run. No need to erase errors every time. Just one time. When you need to erase, it's like if you're using like an application that performs the pairing, like you have paired to iPhone app, you've erased, you may need to erase, so you can erase the bounding and so that. Okay, so good. And as you can see here in the development kit, it is advertising. Let me just, and it is advertising, as you can see there. Good. Now let me remove this one here, and let me check my phone, see if the board actually advertises. So let me open phone here. Let me try again. Just open the software that is responsible for accessing the phone. Here. Nice. Let's move back. And for that, as I said earlier, I'll be using the nRF Connect to check that. So, and here we have stop scanning. It is already scanning, as you can see here. And they have many other devices, and in the devices we have the development kit, and this is it. Let me connect to it, or let me first enable this one here so you can see it is advertising now. Also, let's enable the UART here, the terminal emulator, clear all that. Let's even reset the application so you can see what's happening. etc initialized, tester application started, this one here, this is it, what reports. And here we have the fast advertising. This is the advertising function. Okay, put that here, and let me add. Okay, now let me connect to it. It is connecting, and the LED tone is solid, and here you have here in the terminal emulator down connected. Good. Sorry. And here we have, and here as you go, we have the custom service. This is our custom service. It is already added. As you can see here, the let me remove this one. Administration, this one here. Good. As you can see here in the advertising in the BLE underscore cast service, you can see this is this is our service. It is here. See, we have 00000, and we have 1000. This is the service actually. You can see. So what's happening here is that this base user ID is used to build the services. The UIDs for the service and for all the characteristics. What's gets changed updated is this part here. See, this is what gets changed. And as I told you, this is in reverse. So the end will be 22. This is 1. This is 22. See, good. Now we have the 00 is the service. 1000 service. The thing about this base here is that it is easily you need to check your custom services. You just check this part here. So we have here, this is the service characteristic, which is this one. This one. This is button state. Next one is the potential level characteristic, and the third one, which has the 1003, which is the LED states characteristic. Good. Now, as you have added the custom service initialization structure here, there is also the event handler. So let me look into the services init here, and here we have the services, the custom service. This is our custom service, and it has the handler here. And as you can see here, we've added the event. So if this event, like for the notifications on the button states occurs, we'll have this little login here. Okay, so let me start with what? Okay, let me start with the button states. Let me enable notification. Here, as you can see, this UI application here, this is the characteristic. It's an unknown characteristic, because the custom service was will have unknown characteristic. The application doesn't know what this characteristic is about. This the names are actually assigned for the SIG adopted UIDs services. It is for the SIG adopted services. So for example, if you have the battery service, it will show here the battery service. If you have like the device information service, it will show the device information service. Same for the head, like for the head keyboard service. If you have it, if the application have this service, it will show here head service. We'll see that when we add the battery service. Okay, so first here, let me enable notifications. So we have here the name service, we have the UID here, and we have the properties enabled, and here the descriptors. As you can see here, as you know, we have the properties notify. So we'll have the client characteristic configuration descriptor. This is the CCCD. This is what it can, and this is it has the. Okay, now this is for reading from the characteristic. This is for reading from the characteristic, and this is for enabling the notifications. And here, as you can see, the notifications are not enabled, so let's enable them and have a look at the terminal emulator in this figure. As you can see here, we have this login. So button states characteristic notifications are enabled. This is what I've said here. See, and it is said here. You see, value notifications enabled, and actually pressing this value here will write to this client characteristic configuration descriptor. See, and we'll write a value, so it enables notifications. Let me disable it. Just press this one again. It is disabled. See? Okay, the next one. Let's enable notifications. See? potential level characteristic notifications are enabled. The other one, let's disable them again. Then disabled. Good. Now let's try with the one that has the read and write properties. Let's actually do it first. It's another test. Okay, so we have the notifications enabled disabled here, and this one is for read. It's for reading from this characteristic. These buttons here will be populated using from these properties here. So if you have notify, this is for notify, read, this is for read, and if you have a write, it will have this little arrow here, pointing to the top here. If you have three properties here. Good. Now let's read from it. If we read from it, we didn't send nothing from the application side, so we just have 000. This is what we've set here in the initial value of the customer service with the custom characteristics of the characteristics. So this is the first one, the buttons, and we've set the buttons to 000 to A0. No. The problem here, why I have set here the initial value, you cannot actually just ignore. You cannot. It is not mandatory to set the initial value. But if you don't set it, you will have random values here. Those are now maybe values set by the BLE stack or something. This is why I have 0 here to set to 0. Cool. Same thing for the other one. If we read, we have a 0. This is the potential level. Next, this is what characteristic. If we read from the LED state, we have a 0. See? Now, let's write to this characteristic here. Write into it. You can write many data types here. You can use many data types, but here as it accepts just byte. So this is the LED's characteristic. So it will accept two values, two bytes. So the first byte, let's make it just 1. And actually, as we are just turning on and off the LEDs, we'll just send 1 and 0. And to add another part, you just hit this one. No, sorry. Here is this one. Add, and we just stick it to 1, and hit send. Have a look at the no. What's that? Oh. Okay, let's try. Good. It accepts two digits. Okay, so as you can see, this is the new state 0 and the LED 1, new state 1. Good. I just set them here, as you can see in the. Let me let you know. You can see just I have an array. So if this array will have 2 values. So the first one will be 0 and the second one will be 1. So the first one will actually host the value for the LED 3 and the other one for the LED 4. Good. That's good. Next, we'll be adding the custom we'll add the battery service. Cool, just stretch that so you can see it more clearly. Cool. Next, we'll be adding the battery service. So for that, the battery service is actually available in the nRF52 SDK. So we'll just import it and add it to the initialization function, same as the other one. So for that, you need to include, head over to the top, and here after the custom service, that it include BL_bus.h service. And for that, you need to initialize it. So just look for the services _init. Here in this function here, we'll be adding the battery service. The battery service actually comes with some parameters that we need to set first, and this is the function for initialize it. Same, we have error code, bus init, same as custom service, memory set for the initialization structure, this one. And here we set the read security. This is the CCD, as it has a notification property. This is the report read security. Also, we have the event handler. We don't need event handler here. We don't need this event handler. We'll just make it null. We don't need it. Oh, let's make it null. We don't need it. This is support notification is true. Or report null. The initial battery level 10. The service actually sets all these here. For our custom service, as you might see, that we have already set the read access and the write access. We've set most of them in the custom service files. And here we just had the event handler, but here we don't need the event handler, because the function that we'll be using to update the battery levels, we just send them. If the application is connected, it will take the application can then start the notifications and get the notifications. But if it's not connected, there should be no error. It will actually be an error, but we don't handle that error, as we know that this error will occur if the application is not connected to a device. The problem here with the notifications is that tracking them is not easy, because you don't know, because the client might enable the notifications and suddenly the application disconnects. So you need to see so for example, if you set to just use the function, the updating function, whenever the notifications are enabled, you may just for the event handler put a variable there and turn this variable on when the notifications enabled. But the problem here is that when it disconnects, the notifications disconnect. So when the client want to receive the notifications again, it should again enable the notifications. So you need to track all that, and it is hard to track them all. So you don't know what will be happening, because it might disconnect, and it might just here, like for the events. Let me just show you. Like for the event, for the application events here, as you can see, it might be disconnect because we have a event timeout here, and we have. So what you're gonna do is just add a variable here that the application was not enabled. Disable notification here, and disable it again here, disable it again in the disconnect. This is not good. So for that, what we're using an application that will just send notifications. The application, the function that will actually send the notification to the BLE will report errors. So if the application is not connected, it will report an error. If the application is connected but notification not enabled, it will report an error. What we're gonna do is just ignore these errors. All these errors, ignore them, and just be specific about if something wrong beside that. I hope you get what I'm want to say. Okay, cool. Now we'll be adding the battery service. Okay, let's make it a little bit bigger. Okay, this is the custom service. Okay, we've added the battery service. This is the battery init. Cool. I will just copy this one and put it in right after the custom service init and save it. But here, as you can see, if you are accessing this one here, with this one, mouse right click, go to definition, and .c file. Okay. First thing, we need to add the service, as we have done here, adding the BLE_cast.c file. We also need to add this service file .c file. For that, we need to add a folder, new folder here. Folder will be named this is nRF _BLE _services. So this folder will host the BLE services available in the nRF5 SDK. So here BLE add in this folder here, we're gonna need to add the existing file, and we'll be looking for the BLE_bus.c file. It is located in the nRF5 SDK in components, BLE services, BLE bus, battery service BLE bus. This is one. Good. For adding it to the user included directories, it is already included as other services. See here, this is the service, and as you can see here, it is returning 1, 2, 3, 4, 5, 6 times. Then it found this components folder there, as you can see here. Let's see. So for a figure to get that file there, to get that file folder, it needs to back 1 times. This is 1, 2, 3, 4, 5, 6. So it's need to back 6 times. Then in that 6 times the directory, it will find this component, enter the components, then enter the BLE, then enter the BLE services, then enter the BLE bus, then get this file here. That's it. And this we have already that included here. And just make sure when you are working on this user include directories, make sure there is no space left. If there is any space after that, it won't get that file. It won't find that file, because there is no trimming. It's like it will be looking for BLE_bus with the space folder. Cool. Now, okay. Now, if you are accessing this, when you access this BLE_bus.c file here, you can see that it is green. It is not used because this service here, as also other modules in the nRF52 SDK, are also enabled or disabled using these using the configurations here available in this SDK config file. So here, if you are looking for, just look for bus. This is our server. Just look for bus and okay, battery service should be. Okay, let me look for battery instead. Good. This is it. This is one. This is the configuration that is responsible for activating that battery service or for enabling its files here. Okay, so what I'm gonna do, just copy this one, and in our application configuration file, just place it here and set it to 1, so it is enabled, and save it. Now we have BLE_bus service enabled. Save it, and now if you access the BLE, you just close it and access it again. You can see it is enabled. Good. Now let me close all that, close all but this, and now build and run. Good. Okay. We've not yet added the function to send battery levels, as we are not yet have added the function for reading the battery levels. So this will take some time here. Okay, what we're gonna do? Okay, just some tips here about Seger. We are waiting. So we are here far. We have here edit. This is the view. So this is the view that enables those. So we have here. This view here is called the Project Explorer. This is the Project Explorer. So if you don't have that enabled, like close it, you just hit view and press Project Explorer. This will enable it. Cool. What's that thing? Okay. Next, I don't know if it will. No, it will not work. If the figure is compiling, yeah, it takes some time. It just takes some time. Okay. So there is this function here in this figure here. This is cool and good. You can just hit in like in these structures here. You can just press mouse right click and go to definitions. This should open the file that this structure is from, and navigate to it. See, this is where it came from. And you can just back, if you just get lost in the documents, like when you're looking for, like you've come to this function here and you want to see what's behind this one here, and just go to definitions. You just go to this one and you just find again you done to this, like you want to check this sec mode here. You just go to definitions again, this one, and like you've come across this folder here and you just got lost. You can just back with this arrow here, and we've come to this one from this function here, from this structure here, from this one to this one here, and this back. You can see it is back to this much because I've navigated back to it. Now it will return to the main. Good. Okay, view. We have the view. The output is the output here. This is the output. If you don't have that enabled, just enable it from here. This is the output. Dashboard. This is the dashboard. And what's cool about the dashboard is that you have this project that you have opened. Like if you have opened a project, you just access it from here. Updates. If you want to go to mail file, you just open it here. Oh, we have an error. It is the same. It is the same as the custom service. If you remember, for the custom service, we have this little definition here. This one. See, for defining the service, we've added to the and you've added here. See this one? We also need another one for the battery service, and for that, let me add it. Let me first check this battery service. No, battery service. See, we also have this one here, so we just copy it. And here paste it, and inside we're gonna call it m_best for the battery service. Save build solution, build and run. To build and run it. Cool. Okay. View. We have disassembly. Debug terminal. This is for debugging. Virtual bar, text edit. You can change the here. If you have these low fonts, you can just hit Control and move your mouse scroll. This shows the upper and lower the fonts, and you can save it. Save. Cool. And you can use this option here to close all the files, like close, you can close this one, or just close all but this, or close all unedited documents. I will just close all but this to leave this main.c file. And as you can see here in this is the project files. We have there's a lot of files here actually. Like for the Initialization, there's a tons of files actually here. nRF drivers, nRF libraries. See, we see with the app button library that we'll be using for the buttons. It is already included here. Good. That's the good thing about using this template project. You have many libraries that you will mostly use already set there. Otherwise, you will just add them here. You need to add them here and open the directories and add the directory there for all these. That's it. Okay, we have the nRF log. This is for the login. If you have if you use a custom developer kit, then you need to, and if you're using this project, you follow using this template project, and you didn't change any board file or so, you might need to have these login here. You might need to connect a USB to UART module on pin 6 and 8. The pin 6 or 8 for the are where these logs that came from, because you know these the board has this G-Link debugger, and the G-Link debugger is what actually these came from. These logs came from, and this G-Link debugger chip is wired to pins 6 and 8. So cool. Let me check this one. It is advertising. Cool. Let's check the. It is disconnected. Scanner. Scan. Just try again. Stop scanning. Scan. And it found it. Let's connect to it. Connected, and here you go. We have the battery service, and you see the name. It's not unknown service. It didn't notice. It did identify it. See, and here in the service we have the notify and read properties enabled, and you know, see the descriptor, the client characteristic configuration descriptor. Here it is for reading from this characteristic. If we read, you can see 100. This is the initial value. We don't change that. We didn't change that. We didn't send any new value also, and this is for enabling the notifications. See, notifications enabled, but we won't receive the because we don't send any notifications. We didn't send any of them. And here I didn't add the event handler, you know, for setting those for you know, for having those saying buttons level characteristic notifications are enabled or are disabled, because the problem here is that those are not useful, because you know that notifications are enabled, but tracking them is hard, you know, because you need to handle that on many times. When the application disconnects, when the application try to connect again, you need to handle all that. And if you know, in any time you just miss it, like the application, like an interrupt fires before you just right before you send the value, that should be a problem. Like when the application disconnects right before you send the notification, you'll be a problem there. There'll be a problem there. You need to handle that. So for that, we'll be using a function, and the error related to the connection, we will not be handling them. Good. Okay. Service is working good. See. Okay, now let me. What are we gonna do? Okay. First, buttons. Yeah, the buttons. Let's add the buttons as the library is already available here. Let's add them. Okay. So first thing first, you need to do is head over to the the bsp and the library here. Where is it? Let me find it. This one. Okay. So what we're gonna do is here in this buttons LEDs initialization. Sorry. So in this buttons LEDs initialization function, what are we gonna do? We're gonna limit the BSP library to just control the LEDs. We don't need the buttons. Here for the event handler, the LEDs won't need an event handler, so just we'll make it new. Good, and we have all that. That's good. And here we'll be adding our buttons library. Okay, let me. Good. Now we have two functions that will be added there. The first one is for initializing the app button library. This is for the one. This will have the app buttons. This configuration. This configuration app buttons will have the buttons number, and it will have the button detection time. Okay, so this buttons number we have that already set in the board file. So if we move on here to the board definition, access this board.c file. Let me check. Yeah, board.c file. In this board.h, just right click, and if it doesn't appear, just try again. Right click, go to definition. In this definition here, you can find that we have many boards. See, and we have the board PSI 156 include enabled. See this definition here, where it came from. See, if you go into the project options, then common, then preprocessor, then preprocessor definitions. See, this is where it came from. This is it. So, for example, if you want to add another board and you don't want to change this boards.h file, if you want to add another board and you don't want to change, just change the board.c, the board file, which is the BCI 156 file, you can just add the variable here, like name it a custom boards. You can just say custom underscore board. Make sure there's no space and just copy it. When you okay, when you do that, you need to delete this one. So if you add a custom board, you need to delete this one. So okay, you add a custom board here, just copy it, no space. Okay, and here you see it does that. So if you need to add a custom board here, what you need to do, you just add an lf defined, and we put our custom board here, and inside just say include, and we include the file for our board here. An easy way to include your file is just add it to this folder here. Okay, let me back up a little bit. Okay, so if you want to add, you want to do it the same, but here after that you also need to add this folder header file, same as those. Okay, but let's just change back the here. What I've changed. Okay, let me copy it. Copy options, preprocessor here, and change this kind of bar. I'll be using the nRF52 kit. No space. Okay. So save. It will have this one. So if we're looking where this PCI 156 is available, it is here. This is the board. This is the board file. See, this is the LEDs number, how many LEDs it has in the board. This is the LED one, where it is on the pins 13, 14, 15, and 16. LEDs start. It starts with the LED one, and it ends with LED 4. This is the LED's active state. The LED's active state is 0, means that if you put a low signal on this pin here, it will turn on. See, the LEDs list is this one, LED 1, 2, 3, 4. See, and just make sure that just know this one the LEDs are active on low. Good. For the BSP LEDs, 13 is just same. 13, 14, 15, 16. These BSP LEDs are used for by the BSP library. It has these variables. And here we have the buttons number that we cared about. Buttons number are 4. The button is on 11, button 2, 12, 3, 24, 4, 25. And the button pull up is pin pull up. They are pulled up. So if they are pressed, you have a ground signal, a low signal. Here buttons active state is 0 as they are pulled up. Buttons list, this is the buttons list, and this is for the BSP library, button 1, button 2, button 3, button 4, the same. Good. What about the custom board? An easy way to add, you just add it in this folder here, where the others are. Sorry. Good. This is the all boards that this nRF Sdk has set. CPCA. See, This is the board files we have there. One easy way to add your custom board header file is just add it here. Or you can, if you don't want to touch the nRF52 SDK, you can add it same as the custom BLE service, like in here. Like here, you can add your board file here, but you need to add it to the here in the project to include it in the user directories. Preprocessor user include directory. See here, if you can see, we can locate that the board is included there. See, components / boards, it is included. They are included there. Okay, good. Now to continue here, we have the button snapper. It is already available here. Next, button detection time. This one we don't have it, so we need to add it here. One way of adding it is you can add it to this file here, or you can just add it to this application configuration. Yeah, you can add it here. Just make it define. Button detection time. It is about 50. This is the debounce. The debounce on the button. 50 milliseconds. Let's save it, or you can just add it for that folder here, as it is related to the board. Oh, or just leave it here, no problem. Just leave it here. This should be a problem. Okay, so good. We have the detection time here. Good. The next function that we'll need to add is the app button enable. Is the app button enable? Good. And that's it. We have done with the button. This is for the LEDs, and this is for the buttons using the app button library, and this one is for the startup events. Like if the board was in sleep mode, what will be the wake up button, or no, what should be the event when it wake up, like what it should do when it wake up. Because you know, in the main.c file, see this buttons erase bound. So here it is set to erase the bound. So if the application wakes up, it will erase the bound. So for example, if you have any application that is paired to your device, any application on the phone that is paired to your device, it will now won't be paired, as the application will erase the bounds. Good. Now we have this here. We have this one here. We need to add this little one here. This is the array that will be holding the buttons. So for that we need to add it here. So let me add it here. Yeah, okay, and it will be like that. This is for this button here. See? Because the first one, it takes the buttons number and the button detection time. Okay, so in this function here, as you can see, it is the app buttons. It takes the buttons number, which is how much button we're putting in here. This is the button one. This is actually the pin. Let's look into this one function here, see what it takes. See, the first thing that it takes is the pin number. Next, the active state. This one, if it is defined, it is not defined here. Will not be used. This is higher accuracy. Next is the pool config, the pool configuration, and the next is the button handler. See, so the first thing that we need to do is the pin number of the button. See, this one is 11. See, if you're looking for the button one, this is here. Button one, it is on pin 11. Button active state. Just give it from we just get it from here. Active state. See, and this is the button pull. What is the button? What is the configuration? Is it pull up or pull down or no pull? For that we just get this one from here. It is no pull up, and it is already set here. Good. Next, what we need to add is the button event handler. So if the button is pressed, if there is any event on the button, what function we should execute? Okay, so this is the event handler. Okay, so this is the function, the event handler buttons. Same for the button 2, we have XSA 3 and 4. Okay, next we need to add the event handler, the button event handler. So for that we don't delete this one. It is for this one, it is for bsp event handler. I'm gonna add the function just here, and the function here is this one. Okay, so we have a button handler for the 4 buttons. See, here the button event handler. See, this button event handler takes this already defined there. If you look into the boards, what do we have? See, this is the up button handler. If we are looking to this button handler here, see, it takes the pin number and the button action. So the first one is the button pin, and the next parameter is the button action. So we're gonna do a switch button pin. So if it was the button 1, the action came from the button 1, we'll check what is the action. Is it pushed or is it released? Those are the 2 events that you can get from the app button library, and it is easy, as you can see here. The case which you just see for the button pin, and the next thing you check is for the action. Is it pushed? It is pushed. Is it released? It is released. Cool. Same for the second button. Another little note here for these cases is that make sure you add a bracket here to host all these things here, all these instructions here, because probably you may forget to add a bracket here at the end of this one, and you may get errors that you don't know what they are about, as there are many brackets here. Okay good, so just open one, create the function, and next. Good. Same for the button 3, same for the button 4, and here we close this one, we'll close it. Cool. And that's it for the buttons. So let's add a function here. But before that, let's test that. So let's save it, and let's hit build and run. You don't need to add the library actually, because it is already added here, and it is already added by some other header files. Okay, it will take some bit time because we have changed this configuration folder. No, we are changing the app configuration folder. Okay, there's also another configuration that you need to know about. It is related to the buttons, which is, let me look for found, Control F. It is okay. Let me look at buttons. You need to make sure that this one, yes, this one is enabled, and it is already enabled. Next, and now it's not the accuracy. Okay. Oh, it has a name. Right. And it is used like when you add more buttons. Here the application supports that 4 buttons, and it is set for 4. If you add more buttons, you need to set them to add more buttons there, to add the number. Same as with like the vendor specific UIDs. Okay, the name. Okay, well, it is compiling. Okay, I have this little tool here that you can open this SDK config file, which is this one, this CMSES configuration wizard. If you don't have this one, let me just open it first. Is it still building? Yes, it is. But I don't know, this one is not this is it. This is the configuration. This is an easy tool to check these configurations here. But the problem is that if you change this SDK here, if you change this SDK here, these might not be detected, like here, might not be detected properly. As you can see this E and O and E, all these are used to have this this tool here read this configuration file like this, is in a GUI and general user interface. Okay. I will let you know how to add this tool here in a second. Okay, so let me check for the buttons. In the nRF52 library, should be another libraries, I guess. Enable GPIoT. Okay, let me check. Found GPIoT. I'm not sure if it is even included. Okay, we'll see. Let me check the buttons. Here is the app buttons. Enable accuracy now. Yeah, this one. Yeah, this one. It is GPIoT configuration number. GPIoT config now. GPIoT config. GPIoT underscore config underscore no. This is it. So here, these actually the app button library is using this GPIoT to get the level, to get the battery, to get the button states. Okay, so here it is set to 4. So the maximum that of the events that it can get here from this GPIoT here is 4. And here we have 4 buttons, so 4 events for 4 buttons. But if you have more buttons, you need to increase that. So you need to make sure that, so for example, if you're using 6 buttons, or no, I don't know, 10 buttons or something like that, you need to increase them. For example, if you use 5, you need to make it 5. If you use 6, you need to use 6. But here, as I told you before, don't change that here. Don't change it here. Just take this one here, copy it, and paste it in your app configuration file and change it there. See, don't change it in the SDK configuration file. I just changed this one. It is not should not be played. Okay, see, now it is advertising. Okay, let me close that. Yeah, but yeah, first thing, let me tell you about how to add this one here. So how to add it is that you need to go to tools, I guess. No, it's not here. I think you just hit on this folder here and just I think options. Yeah, options, common. Okay, let me just check here. It is available. There is a tutorial on how to do that in okay. And here it is. Yeah. This tool actually is already available in the Sdk image, so you just need to enable it. So for this, you just need to File, open Studio folder and external tools. File, open Studio folder. File, open Studio folder. External tools configuration. Hey, wait. It's an XML. So you add this here. What it is? This is it. You add these lines of code here before the tools. Before the tools close. You just add this little one here. And to get that one, you just head over to this page here and just copy this one here. Yeah, and you'll have this tool here. It is easy to check these configurations here in the Sdk configuration file. Cool. Now let's close all that and let's head over to our terminal emulator and let me enable the video. What's happening? The board does not look advertising. Okay, let me try and build another one. Oh, I think okay. You just go and sleep. Okay. Okay, let's test these buttons here. Let me press the button 1. See, if it is pressed, if I press it, keep pressing it, it is pushed. If I release it, it is released. Let me try with the second button. Button 2, press it, push it, release it. Press the second button, the third button. Now it's pushed, release it, it is released. The fourth button, press it, push it, release it, release it. Good, that's it. It is properly working. And the LEDs are still working because we've set the BSP to handle the LEDs and the upper button library to handle the buttons. Okay, let me close that. Good. Now we've added the buttons. We've added the okay. Let's add the function that will be used to send the button states. So for that, we've already added that here in the service, in the custom service. This is the function here. Yeah. This is the function. So let me just copy this function. Yeah. Just copy it. Okay, but first thing first, we need to have a variable here that should host the battery states, and for that we'll call it static, and it should be volatile because the battery, the buttons states will change in an interrupt, in an event. And okay, volatile uint h_t, we'll call them buttons_states. This will have 4. I will be okay. So will be 0. Okay, 0 here means that they are released. So 1 will be pushed. Good. Now for the function that we'll use to update these. That will be using to update these button state is this one. Just put it in. This is it. We just create another function. Create another function. Name it buttons states update. Now the button states. Okay, let me change this one. This will be m underscore, and we'll be button states for. Here, what we're doing here is that this function here will not accept a volatile does not accept a volatile variable, and it will report a warning when we compile. It will work good, but it will just report a warning. Anyway, what I've did is just create this one. This will host the button states, and this one will just take these button states and put them here. So 0, 1, 2, and 3. See, 0, 1, 2, 3. This is this one here, and we have this one here. Good, that's it. Now this is the function. This is the function that I have copied from the here. This is the function, and it takes the custom service structure, button states, this one, see, and the connection handler, which is the application connection handler. Good. See what I've told you about not caring about all the states, about all the other connection related errors. So for example, if we will check if this error, if this function here doesn't report nRF success, but okay, doesn't report nRF success and doesn't report connection invalid, and doesn't report invalid states. Invalid states means that like the notifications were not enabled. Next, here gets system attribute missing. Something is missing in the get. So we don't care about all these errors. Okay, so to check the error here, as you can see, we need to make sure that the error code is not nRF success, and it is not this one for the connection handle, and it is not this one for the notifications, and it is not this one. So it should be anything other than we should check what it is. Good. Now the next thing that we need to do is updating the buttons states. This one, need to update this one. Okay, for that we need to have a function. We need to add a function to easily do that. The function is used to get the button index. So what we're applying this function, we will apply the button pin, and this function will give us the button index. Means because as you can see here, as you can see here in the board file, we have this array here, the buttons list. This is the button 0 index 1, 2, 3. See, so the thing here is that to make it easy for us is that we use this function. We give it the button pin, and it will give us the button index. So we take this button list. This is the way here. This is the button list, and we put that in a buttons list, and we check this button list. If it is if the button pin equals to one of these buttons list, we return E. This will be the index of the button. And so for that, when the buttons change, which is here, just put here before the, just put this one. So in buttons states, so actually here, this function here, this event handler will occur every time a button has an event change or states change. So for example, if one button change, each button, whenever a button change, we'll set this one. We'll get the action, we get the button pin, we check the index, and we get the button action. Okay, so the button action here is yeah. Okay, so we set the button action, and we place it in the button index, in button index in the button states array. See here, and after that, we update. We set this function. We update the button states. And that's it. This is m button states, get buttons index. We get the buttons index, put it here, get the index, and we set that to the button action. The button action actually is push or release, and push and release are 0, 1. See, the push is 1 and the release is 0. See, that's why I've set 0 in the buttons action. Sorry, buttons action here. See, associated to 0, so those are released, and here also the same here. If you have the release, G will be 0. That's cool. That's an easy way to handle that. That's what I was saying. This is easy than, you know, pushing it every place in here. You just add this function here, get the button index, and set it in the button states array, and then update button states update. Good, and save it. Then we'll run the run. Let's check that. As you can see, the board go on sleep. Okay, just compiling. And as you can see here, if you have more buttons, you just add them here. And remember to update, to change the related configuration. So to add the GPIoT event means how many events your application or GPIoT events will receive. Okay, let's close all this. Okay, well, let's compile in. Let's proceed to the next part, which is for the LEDs. Let's set the LED state. So that should be in the event, in the custom service, when we receive this events here. See, so for that we're gonna need to use a function here. Let me just locate it. This one. Okay, this function here and as just another note, as these functions are static here, you need to make sure that this function, the function is declared before you use it. If it is declared after you use it in a function, you need to include this one here in the header. You need to do like this, like here for the advertising, for this function here, for this advertising style, because this function here is used before it is declared. That's why it should be declared first here, just the function. same as we do in the header files. Okay, just to header file, just to 55, I guess. Cool, and this is it. That's the function that we'll be using to set the LED states based on what we receive in the LED's state characteristic. Okay, let's make it LED state underscore characteristic commands handler. So as we said, we get this function will take commands very constant. This is the LED state, and we should length with these commands. We have an error code, and we use this for function here. This for function here starts from 2 till length plus 2. The length of the commands is 2, so it will be from 2 to 3. So it will just has two indexes, 2 and 3, because here the 4 we won't get to the 4, because on E less, the condition is E should be less than 4. Good. What we do here is that this command here, which will be the LED state, we take the E minus 2, because the commands will start from 0 to 2, but here E starts from 2, so we're gonna need E minus 2. So if the E equal to 2, this will be equal to 0. So we'll check the command 0, like for the first LED will be 2 minus 2 is 0, so command 0. If it is equal to 1, means that if the LED, if the application send 1 on the first command, on the command 0, this is for the LED. Okay, this, if it is 1, what should we do? We need to turn on the LED tree. So for that, what are we gonna do? We're gonna BSP. This is a function used a BSP function used to turn on the LEDs. So the cool thing about using these functions here is that it takes in consideration the active state of the LED. So you just set the active state in the board file and just use the function. It will get that from the board file. Good. So if it is 1, we'll turn it on. If it is else, means it is 0. It should be 0, because it will be 1 or 0. This will be sending. If it is not 1, it will be off. Good. We could also make it better like if it is 0, because there is 0 and there is the other thing. Okay, let's make it 0 here, and this will be reverse. It will be here off, and it will be here on. Cool. And this is the a core function here. It's, you know, this little question mark here. So what it does is that it checks if this instruction here is true. So if the command 0 is 0, this means that the board 0, the board with the ID 0 will turn it off. And same if it is other than 0, which will be just 1, because we just said 1 or 0, it will be on. That's it. That's good. The thing I see about these two here, because the thing here, we are controlling the LED 3 and 4, and the LED 3 and 4 has the index 1 and 2. So no, it has the index 2 and 3, because we have 4 LEDs. The LED 1 will have the index 0, second one will have the index 1, third one will have the index 2, and fourth one will have the index 3. So we start from here, from 0 here, but here it is 2. See? Hope you understand it. That's an easy function to handle that. And you can see it's just a one line instead of making if statements. Good. And after that, we need to, you know, include this function here. After you have this function will check the command. Yeah, we'll check the commands. I'll check. This is where we get that. So we get the data. This first one is the data. Here we don't have the event. We have this one here. P event params command data p data. The next one has the length. The next one is length, right? Length. NGTH dot LEGTH. I have some problem with this TH. I always make it HD. Okay. Good. Okay. We have flashed the LEDs update the buttons update or updating the button state to the development kit. Let me check here. So we have okay, first thing, let me connect to the board from here. Scanner, scan in, connect. So we have this one and this one, and we have no. We clear, and this one here. Good. Now we're connected. We have the our custom service, and first one is the buttons. So let's enable the notifications, and notifications are enabled. And let me press the first button. See, I am pushing the button now, and you can see the here the value has changed. Let me erase it. Release button. See, it is released. Let me press the other one. Press it. Let me release it. Release it. The fourth button. This is the fourth button. Press it. Release it. Let me press the other one. It is good. Let me press two at the same time. See. Let me press two and the other. See? Cool. Good. The thing is that if you what's another tip? If you disable notifications, you won't receive that. See? You won't receive these changes, so you need to make sure you enable notifications. Or you can just just read from it. Okay, here I'm pressing the button, and let me read. See? It is. But it won't change because the notification is not enabled. So for that, if I read again, it is released. Good. What else? Yeah. Let's flash the next update. Okay. So build and run. Another note again about Secret is that the application also comes with the soft device, which we are using the S124, and again, as you can see here, it flashes both the soft device and the application and our application. Cool. Now open this terminal editor. Let's clear all that. Let's open the app. Let's have a look at the LEDs. Okay, let's connect. It is disconnected now. Let's click this one. Scanner. Let's clear this listener here and scan. App connected. Cool. Now open the service. Where is the LEDs? This one, which has the right. The read on the right. Okay, let's this one is for reading. Yes, just 00. They are off. And let's write to it. The first value that we'll be writing to it is 01. The other one that we'll be writing to it is 00. Let's send it. Cool. See, you have the LED 3. Turn it on. That's good. Now let's try again. Let's make it 00 for the first one and add 00 for the other one. Send. Cool. And you have the LEDs off. And you can also have these little here, these login here, this URL login here. See? So you can. The thing about this project is is that you can port it to your project, and you can build from it. So for example, you want to send other data beside the LEDs, you can use that. Beside the LED states, you can use that. So for example, let's try that. So let's write here, let's write this is the hex value, so let's just make it a what else, a 10, so it will be 0A. Next one, let's make it an 11, so 0B. Send. See, there will be both on, and you can see here you get these values here. See, you get this 10 and you get 11. See, you can you can play with that, if you want to turn on the LED based on what number the application sends you, and many of that. Good. Now let's another last test is send, and here as you can see the value is set. If you read from this characteristic here, it will be this value. Let's write to it and write 00 here. And as you can see, you need in this application, you need to make 2 digits. So, and they are off. Cool. Good. Now the next thing that we need to do is, what else? I think, we need to add analog readings. So first thing that we need to start with is, the first thing that we'll be starting with is the Saadc. We need to set the Saadc peripheral here. We need to add it to the application. Okay, so first thing first, we need to add a file here to the nRF drivers. This will be the nRFX Saadc.c file. So for that, here to this little here, add existing file, initiator to the BLE peripheral projects. Anyway, to the nRF5 SDK, then to modules, nRFX, drivers, source, and look for the nRFX underscore Saadc.c file, this one, and open. This should add it, and you don't need to worry about the adding the include directories, as it is already added there. The modules folder is already added there. So if we look into the preprocessors here, this is the components. Here we have. See, this is the modules where we got our nRFX Saadc.c file. This is what we got. We will have added. See, we also drivers include added of that, and make sure as I have that, because I have got many problems in that in the first days I've learning when I've started with the Cigar Embedded Studio, is that sometimes you add a space here. Make sure you don't add it. Good. Okay. Now, next we need to add here we need to add the header file for the library that we'll be using. So actually it is, the library is this one. It is the driver, is the nRF driver Saadc. Save it. What else we need to do? Next. Okay. Okay, we have added this one. Next, we need to add a function to initialize the Saadc. This function will be and actually the Saadc will be used to get both the analog reading. To get the analog reading, because we have one Saadc peripheral. So for that, this is the initial function. This is for initializing the Saadc peripheral. We have error code, and we have here we configuring the channels. The Saadc has each channels, has each channels. So and here we will be reading the potentiometer analog value and the SR, the battery voltage. So for that we need to set two channels, or we need to configure two channels. The first channel here, and this is the structure for configuring a channel, and in name the channel 0 config, and there are actually many configurations to set, but to easily do that there is this default configurations that you can use. We're using here the is also the single-ended nRF driver is this default channel configuration single-ended. If you're looking to this single-ended configuration, go to definition, and in definition you go to this one here. See, the drivers definition are forwarded to the nRFX definition. See, okay. Here, see, the only thing that you need if you are using this configuration structure here, the only thing that you need to set is the positive pin. See, the resistor pin is disabled, gain is 1/6, 1 divided by 6, gain reference, this is the reference internal, this is the internal voltages, acquisition time 10 microsecond, mode single-ended, burst disabled, pin. This is all good. Okay, we'll be using this function here and as it said, you'll just need to configure the pin of the yeah, you just need to configure the pin, positive pin. Okay, for that the first thing that we need here to add, we need to set a channel for reading the battery, the coin cell battery voltage, for reading the coin cell battery voltage. And here for that we are using the coin cell battery. It's just a 3 volt, so there is no need for any resistor driver, so you know, to cut down the voltage. The coin cell battery is actually wired directly to the development kit. There is no voltage regulator in there. So what we're gonna do is just get the VDD. See here, we're just reading the VDD. So to do that, just read the VDD. Just put here nRF is DC input VDD. The VDD has no input, so you don't need to. It won't be a hardware pin. So for that. But if you are using a battery like a rechargeable battery, you might need to look into this guide here. Let me just look for you. This is a nRF52 dev zone battery. Okay, I'll add that battery. Okay, it should find it, hopefully. Yeah, this one. This is how we're gonna do it if you are using a battery level. If you are using a 3.4, a 3.7 battery, like a rechargeable battery for your project, this is how we're gonna do it. You're gonna need to check this tutorial here. It's good. It tells you what to do exactly for a good setup, and what you should be aware of. It's a good guide, actually. Anyway, for our application, we're just using a 3 volt coin cell battery, and we don't even need a resistor driver. Good. So okay, so for the next channel that we need to configure is for the potential. For that we need to set the pin here for the same configuration. The pin here. Okay, so the pin, I've put it in the pin tree, in the third pin. Okay, let me check. I've created a analog reading. Here, just showing a picture for you. That's the one. This I've created. I've created this one here, just for letting you know for the pins, you have in your for the analog pins on your developer case. It is available in the NRF info center. It'll just get a while to get to there. Anyway, here it is. So the pin, the IN0, which is the zero, the first analog pin is on pin 2. The IN1 is on 3. Second one 4. Third one on 5. Fourth one is on 28. The fifth one is 29. Sixth one is on 30, and the seventh one is on 31. So I'm using the pin 03, this 03 here. So my analog input will be set to IN1. So for that, here it is. Let me okay, so I have a variable here. So let me give you what okay, I forgot to define that. Just define just here. We will get to the top. Anyway, this is it. See, it is the NRF Saadc input IN1. It should be this here. It should be this in this format. It should be NRF Saadc input IN1. This is for pin 3. For the other pins, you're gonna just change this one here. So, for example, if it is pin 2, this is the 0, so it will be 0 here. And you can same for the others. Good. We have this one, and here we initialize the Saadc. This is for the event handler. We don't add that. Now for the configuration, I guess. Anyway, you just init the Saadc here using the Saadc callback. We'll add that callback in a minute. And here the channel, initialize the channel, the first channel here, and set to 0. And initialize the second channel and add it 1. If you add another channel, you need to make it 2, 3, 4, 5 till 7. You know, and make sure this lightly here because I say structure. So on. Okay, next you need to set the buffer here in the driver is at this buffer convert. This buffer here will hold the values that will be converted, because you know the Saadc will just sample. These samplings needed to be converted to analog values that we will be using to get the voltage, the rated voltage. Okay, so for that we need to have a buffer to store all these values with the Saadc samples. So on each sample we just put the samples in this buffer. Each samples we put the samples in this buffer. Here you can see we've added 2 buffers. This is for example when the Saadc samples, the first samples will be placed in this first buffer. Once this buffer is full, we start the conversion. See, while we are doing the conversion, the Saadc can still work and sample other values and put them in the other buffer. See, so for example, so if we're done with the first buffer, we'll go to the next buffer and he will just start again with the first buffer. See, so it's just we have another buffer available, so the Saadc can put in its new values while we are converting the old ones. Okay, good. Now here we need to add some variables, like this is add these samples in buffer. This will be just 2. We just put 2. This is the minimum, as we have 2 channels. samples will be 2. Next we have this next we have the buffer. We set the buffer, see. Good. Next we need to set this callback function here. So copy file. Okay, let me set add the callback function. But before that, let me clear this one and add them to the top. The definitions to make the application a little bit clear. The thing that you can add, you can do in if you are in your development is that the Sdc functions, you can add them to another folder, like in another library, and just you know, make the calls to the libraries. It should be good. Also for the Bluetooth, you can do that. Like make another library which hosts all these Bluetooth related functions and just get them from there. So the codes on your main.c file is small, and also everything is managed and clear. So if you can just go to the advertising library and check all that. This is advertising parameters, advertising everything. Same for everything else in your application. Same for the timers that will be getting to in a second. Okay, so what we're gonna do is set the Sdc related definitions here. The first one is the potential analog pin. The next one is the Sdc is the samples in the buffer. The next the next is the buffer pool. We also need this little one. Okay, let's add it here. We need it in the callback function. Next, we also need to convert the analog values we read from the Sdc peripheral. We need ifunction. The function, the formula actually is available here in this link here. Let me open it. For you, this is for the in the info center. It is loading. 1 second, please. Okay, good. This is it. See, if you head over to see here nRF52, your SoC, then head over to peripherals, then Sdc, then digital output. See, if you want to learn more about Sdc, just head over to this one. It'll have a lot of information in there. Okay, so digital output. This is digital output, how to calculate it. So the result, which is the analog, which is the value, which is the converted value. So these are the samples, and this sample converted. So the conversion, after the conversion, is the result. The result is equal to Vp. This is the voltage on the positive minus the voltage on the negative times the gain divided by the reference times 2 in the force over resolution minus m. This m here is, see, is 0 for single-ended channels, is 1 for differential channels. We're using a single mode, a single-ended channels, so it will be 0. I have calculated that for you, and here it is. So we have same as formula here, and here we have the resolution for the Sdc here is 12 bit. That's the maximum resolution that we can get to. There is a the Sdc is also capable of 14 bit, but this is for one channel. So if we have just one channel, you can set the resolution to 12 bit. If not, no. If you have one channel set, you can set the resolution to 14 bit. If not, the maximum is 12-bit. This is for the nRF52, I think, all the nRF52 series of SoCs. Anyway, this default for the SO single-ended. We're using a single-ended mode configuration. VN voltage on a negative pin. There is no voltage there. The gain is 0.6. This is what it is. See, that's where it came from. It is 1.6. Reference voltage internal. This is internal. It is set to internal, and the internal voltage, internal reference voltage, is 0.6 volts. Good. Next, the M is equal to 0. I have calculated that, and I got this additional voltage. So move these to the other side and got the VP, was well considered about the voltage. There is no negative pin, so it is 0. So we have just a positive pin, and here this reference, this result reference, I put it. So I have added this definition here, so we can easily just put the result, and with the result you can get the voltage, and the voltage here is in millivolts. Okay, good. Now, so I have calculated all that. The problem here with this compiler, with C. Anyway, the problem that will be here is that if you add the function same as it is, like with the slash and with the forces and everything, if you have like a division here, it may be 0. For example, this here, if you have a 1 divided by 6, that's a 0. Let's say they say 0 in an integer. That's an integer. This will be treated as an integer calculation, and it will be 0. And if you have 0 here, everything this will be 0, and 600 divided by 0, you'll have a warning, and this won't work. See the problem? So what I've did is just calculate it. So what will happen is that we'll take the ADC result and times it to 0.67 87890625. Good, that's easy. You can also use this function for your needs. And if you will be using the 14-bit, this should be changed. This will change. And if you're using like another configuration, this also change. Good. Anyway, this is the default configuration. It will be like this. Good. Next, we set the buffer, sample the buffer in 1. Good, buffer here. Cool. Next. Yeah. Next is this one here. No. First. Before that is that as I told you, the Sdk will first sample, then convert sampling, then from the conversions we use this function here to convert them to get the voltage to give the voltage of that pin. The problem here is that the Sdk won't sample on its way, so you need to trigger that sampling. So for once your application started, you need to trigger that sampling. So for that we need to have a timer. It is easy to put it here, to add it here to the loop, but the problem here is that in this for loop here we have this idle state function here. This function actually sleeps. Next, the application sleeps, not the deep sleep mode. It's like a sleep mode, but the application is still running. It's just in the minimal on the minimal power consumption. It is this is one. See, if there is no log process, no log like this one here, it will run the power management, and power management will just lower the power consumption. This is different than the sleep mode. Sleep mode will have the application deep sleep. In deep sleep mode, it is like the device is turned off. Okay, so here we have back into the. Okay, so and one tip for you here is that in this for loop you don't need to put anything here. Try to not put anything there, just so it will be just this function here, and make sure everything is handled using interrupts. So you can just enable or disable and it stop it. So for example, here what we'll be doing with the Sdc. Here what we'll be doing with the Sdc sampling. These samplings will trigger them using a timer. Here we'll be using an application timer. Okay, so let's add that. So for the application timer, okay, we'll add in the timer. We'll also add another timer because we also need the battery level to update, and the battery level we don't need the battery update to update each time the SRDC triggers. Each time that we have another new value. No, we would like to update it like each 1 minute, for example. Here in our application, I will update it each 1 minute. So for example, let me start first with adding the timers. So to add the timers, first need to add these definitions here. This is the application timer. You need to add this definition here. No need to add anything to the header files, as it is actually already added. Next, you need to set some intervals. This is for when we will start the timers. Let's paste them here. So we have the battery timer interval. This is in seconds, and it is necessary to use this app timer ticks, because here the timer accepts ticks. It does not accept milliseconds or any seconds. It accepts ticks. So for this is why you need to add this app timer here and put inside the milliseconds that you need to be in between the intervals. So it will be 1600, which is the 16 seconds, 1 minute. And here for the SRDC, I just put it to 200. 200. Let's make the 100 either to make it a little bit fast. Good. 100 here. Next, we define the up timers, and next we're gonna need to do. Okay, we need some variables. Okay, first variable here is the battery level, and the next one is the potential level. Okay, let's add them here. They should be volatile because they will be updated inside an interrupt. So we have our battery level and we have the potential level. And I have okay, no problem. No. Okay, we have those here. Next, and as we will be sampling in a quicker time, this is a 100 millisecond sampling, we'll have a lot of values, and I will be logging these values to the UART. So for that, and to limit that, once we have everything working okay, we can stop that. You can do something like this. It's at DC log. You can define something like this. It's at DC log enabled false. Just make it false. But first, I'll make it true because I need to see login. Cool. Next, we need to create the timers. The first timer is for the battery update. This is for initializing the timers. This is the timer. For creating this one for creating the battery timer. This is the battery timer ID. This is upside the timer mode. It is repeated, and here we need to also add a timeout handler. Okay, let's add the timeout handler. This is the battery timeout handler. It is so whenever this timer times out, we need to update the battery level. Updating the battery level is almost the same as as updating the states. So we have this one here, battery level update, and same, we don't care about any other known errors. And here we check the battery level. The battery level will be accessed through the code because it is defined in top. Good. And we save it. and we're done with the battery. Should be working. Okay, now not yet. We should also start the timer. Okay, next is to add is add this timer here. Create the add this timer. This is for triggering the samples. Let's make it potential timer, no problem. I've just named it potential timer ID as we did before, and it has also a timeout handler. So what will be happen when the timer times out? So for example, this battery timer here will times out each 1 minute, but this one will times out each 100 milliseconds. Okay, same for the battery. Oh, I haven't added this one to the top. We need to move it back. Should be here. Close into the other function. Okay, this is for the Saadc. And same, yeah, the function. I made it same as the battery level, So we also have the, oh no, not this one. Yeah. This timer is not for Bluetooth, so okay, what's that? Oh, okay, sorry. Anyway, we create the battery timer, and it is the ID, repeated mode, and we have this is the timeout. This is the timeout. Once it times out, we trigger this function. It is here. Next, for the potential timer, which is this is for the triggering. Oh. Anyway, you can change the name. I think I have a problem here with the names. Anyway, this is for the potential. This is for the triggering of the Saadc. So it should be Saadc here. And I'll change the timer there. Okay, so we have the Saadc timer, timeout under here, and here I have it here. See, the only thing that this function does is trigger the sampling. See. So each time this timer times out, it'll sample one sample. Okay, it'll sample one sample. Just a note here, as we have 2 channels and we need a minimum of 2 samples, this timer here should time out 2 times before we get the samples. Before we can access the samples, because it doesn't no, we actually need 2 samples, so we need to sample 2 times because we have 2 channels. That's the minimum. If you can actually maybe make 4 samples, then have the Saadc. You can do 4 samples, then have the Saadc like a trigger with to handle back the values. For that. Okay, I think I've lost it. Anyway, we have 2 samples, and for that we need 2 samples, and for that we need the Saadc to sample 2 times. Cool. Next. Yeah. Next is we head back to the Saadc init function. Here, as you can see, we have Saadc if. You can add if defined and just comment it if you don't want it, or just make if, and if it is true, it will be true. This code part will be executed. If it is not, if it is false, it won't be triggered. Here there is a callback function. Function here. Okay, the first thing that we need to check.
So this function here, this callback actually function here, will execute, will trigger when the SRDC peripheral has all the samples. So for example, we set it to have 2 samples. This SRDC callback will trigger once we have 2 samples. Means that once the SRDC samples 2 times. Good. So if it is trigger, we just check. Is it if event type? Is it done? Is it event done? Means it is done. Means that if the event is done, this is actually where we get the samples. Yeah, we check if the event done means that we have the 2 samples available. First thing we set here is this SRDC voltage, and we just add a variable here to host the voltages, which is 2. Next thing we just convert the buffer values, the buffer readings. Yes. So here p event data dot time dot buffer is samples in buffer. This how many samples we have in the buffer. Next we add this for here. This is for reading converting these readings here to voltages using the function we add before. So this function here takes these readings here, which are the analog readings, and convert them to voltages. One note about these samples in buffer is that you need to make sure that it is like double of how many channels you have. So for example, if we set it to one samples in buffer, we only get the first sample, which is the sample of the first channel. You know what I mean? So for example, but here when you have 2, the first one will be for the first channel and the next one will be for the next channel. But for example, if we have 3 channels enabled, you should have at least three samples. So the first one for the first one, second one for the second one, and the third one for the third one, and you can get them in this using this instruction here. You can just add a for loop here and get and convert them from the value. Now here we have we said that the battery level, which is the first channel, and as I said in the introduction for the video, this is the battery level in percent. This is the function we're using. This is available in the nRF52 SDK in the util library. See, here it is. And here in the details, you can see it in the calculation based on a linearized version of the battery's discharge curve. 3 volts is 100% battery level. The limit for power failure is the discharge curve is nonlinear. Anyway, if you'll be using this CR2030, you can use this function, but you need to test it before that. This is the function. Cool. Another note about the batteries is that if you have like a 3.7 battery, rechargeable lithium-ion rechargeable battery, is that you need to have a look at the curve, at the discharge curve. This is where we can get these linearized sections. So for example, from 3.7 to 3.6, there will be this value and so like that. Okay, next, the potential level. The potential level here, as I said, it is based on the level. It's calculated based on the level of the VDD. So this is the SRDC voltage 0. This is the VDD actually of 0. And here we go. The SRDC voltage, we multiply it by 100 and we divide it by the SRDC voltage to get 8%. See? Okay, here in the login part is at this event number. This is for the event, for how many events we have. Yeah, and it is updating here. Next, battery measured voltage, millivolt, this DC voltage 0. Level, this is the level, battery level. Potential measured voltage, millivolt, is DC voltage is 1. Next, potential level, and we have this function here. This function will be used to update the potential level. Let me just look if we have it. No. Let's add it. and here it is. It is similar to the buttons, and same we don't care about many of the error code related to the connection issue. Cool. Next, we have this one. Let me check if we we've added. If added it, what else we need to do? Yeah, timers. We have the timers. We should start the timers. So for that, we're gonna head over to the timers section. Application timer start. So to start them one time, the first timer that we need to start is the battery timer. The next timer is Sdk timer, and I have this file here, so let's make it Sdk and save, and let me look if we are good. Yeah, but here it is not. It is set to potential. Okay, let's make it Sdk. Save. But here, make the here. Let's move those to the back. Here. Save. Good. Yeah, we have the interval set. Timers definer. Let's put this timers here before. We should write before the BLE. What else? We have the definitions for the interval. Let's just leave them there. Okay, save. And I think we're good. Good. Yeah. Okay. I think we're good. But here for the Sdk, same as we did with the battery service, we need to enable it. It might not be enabled. Okay, and the Sdk config, just look for Sdk. See here, it is not enabled. And to do that, you need to take these, copy them to app configuration. Paste this one here, set it to 1. Next, you need to set the resolution. The resolution is set to 12 bits. So it should be 2. Next, we don't care about our sample, low power mode. Now, found again Sdk. We have another this one for the application. One, and for the resolution again. Make it resolution, make it 2. Okay, what else? We set the resolution, we enable it. Cool. I think we're good. Let's build and run again. Let me close all that but this. Cool. So okay. So once the application starts, it will start the timers. And the timers will start the battery timers and the Sdk timer. Cool. The first thing to worry about here is the timer for the Sdk. We set it to 100 milliseconds, so that will pop out the values here very fast. We might need to lower it down to like a 200 or a 400 like this. But then it might be, as you know, the Sdk timer needs to sample 2 times before we get before we can convert these values, so we have the two, the SRD, the battery the battery analog value and the potential analog value. Good. Okay, what else? Well, this are the significance. Okay. So yeah, just some notes. This is how you create your timer. You know, you just set the IG in first and the definitions, and set it to IM repeated, and add a timeout handler. That is easy as is. The one note about this timer here is that the minimum is that the minimum. Let me just check. Get over to the application timers start. Once we start the timer, we add this interval here. So go to definition in this at the start, in the timer start. Okay, so say, as I said, it takes the ticks. It does not take the milliseconds. It takes the ticks. Another note about the timer, about this application timer, is that the minimum value, the minimum interval is 10 milliseconds. And as you can see, this is up. You see here, this is up timer 2, and this is what it is included. And I don't know if you have noticed that or not. If you head over to options, common, preprocessor, and head over to the here. Say we're using the second timer. Second timer RTC1 enabled. Proceed flow. This is the SOC. This is the soft device API version. This is the soft device. Is the soft device present? See, and this is our app config. Okay. It is for debugging, you know. What we have? Oh, I see. Here's the build solution, making sure it is good. Okay. Okay. It is a little bit slow. I don't know. What's the problem? Yeah, I know. I think I'm on 99% of the CPU. That's what I think. That's for sure. Even the task manager. Okay, well, that's it. Oh, let me close that ground. Okay, it should be good now. Chrome is still running. Where? With 0%. Windows Explorer takes... Oh my goodness. Oh man. With solution, as you can see here, when it builds, it you get these data. Yeah, because actually it compiles each file. Each file size, compilation size is shown there. Okay. What's the error? Oh, we have another initialization here. Oh my goodness. Real solution. Okay, well, it's built in. Let's turn off the development kit and add the potential method. So, as I said, the first pin will be on the end pin. So the end pin. Just make it a little bit bigger. Let's start with the middle pin first. The middle pin will be on pin 3. The first pin to the side will be on VDG. Make sure you don't connect it to the 5-volt pin. There is a 5-volt pin here. I don't know if you can see it. You can't see it with the mic. Anyway, you have a 5-volt here in the development kit. So make sure you don't connect that. You don't use that. So it is VDG, and the middle to the pin 3, and the other one to the VDG. Cool. That should be good. The thing about the 5-volt is that the maximum voltage that can be the maximum voltage that the SRDC accept is VDD. So if you connect it to the 5-volt, you might just damage that part of the port. You may damage that part on the SoC. Okay. Now let's turn it on. Cool, it's working. Yeah, I'll add the coin cell battery after checking after verifying the so build after flashing the application, so build on the RAM. Oh, something wrong. Yeah, we forgot that. We start the timer on top, and the timer is sampling, but we did not initialize this SRDC. You make sure you initialize it before starting the timers. Let's make it here. Forgot about that. Okay. No. Yeah. Almost forgot. Put it here. Before the application start timers, because it will start. Oh, sorry. Yeah. What I did is that, as I told you, we didn't initialize the SRDC before starting the samples. So what I changed here is that just this SRDC init here, I just added it to this place here. So we initialize it before starting the sampling, which will be starting using the timers here. Okay, let's make a build on the RAM. Good. Should be working now. Clear all that. Enable. See? We have a 100 timer that is sampling, and each sample will take 100 milliseconds, so two samples will take 200 milliseconds. That's why the login is pretty fast. If I'm moving the potentiometer, see the level of potentiometer, it changes. If I move it, potentiometer to the other side, see, it gets 100. Now back. Cool, it is working. So what we're gonna do now, we're gonna disable these readings here, this login here, and we'll head over to the application and see how that is working. So make it false, save, and again. And as you can see, the voltage here, see? The voltage here, it is reading the voltages. As you can see, the voltage on the potentiometer is 1.37 voltage. That's true actually. So let me, I have a potentiometer here. I have a multimeter here. So let me just grab that for you, just to verify all that. Sorry for that. Okay, we have here the cardboard. So, okay, let's see with the, let's start with the potentiometer. Potentiometer is voltage saying 1.2. Okay, so what is the voltage? So we have the pin 3 here, and as you can see here, I don't know if you can see that. Anyway, this line here, is for the ground, so I'll just put a ground here, and the other pin will put pin here in the point 3. See? It is a little bit close. It is showing 1, 2. This is 119, 120, 119. So now we will see the false and we'll run. Just I'll be adding the coin battery, and we'll look into the Bluetooth side. Cool. Okay, let me turn on the board. Let me remove that. Let me add this coin battery. And there we go. Okay, now to the application, to the nRF5, to the nRF Connect mobile application. Oh, sorry. Okay, scanner, refresh, connect in this. Let's subscribe to this one. It should report the battery level in a second, as soon as the 1 minute passes. Next, we have the potential level is on this one, right? See, it is moving. I'm moving the potentiometer now, and it is pretty fast. Because in the old test I've done, I've set the the interval to 200. Now I've set it to 100. No, I don't know. Yeah, 100. So it's pretty fast now. Cool. And the Bluetooth is still handling that. See, the value is ERX. See, and there is also this cool. And there's also this ASCII conversion, if it is an ASCII. Cool, it is working. Good. Now back to battery. See, we got a level 17. Cool. And that's it. I think that's make it. Hope you learn a lot of things from this long, I don't know, 3 hours. The next, yeah, we'll also have another, I don't know, 1 to 2 hours for the application. We'll be building the Android application using the Ionic framework.